We couldn't find Scott Walter this morning, so we decided to bring on something. I'm not quite sure what we're looking at here. Scott, you're all hooked up. You're
Yeah, I'm wired. So yeah, I think, do you see some robots behind me?
yeah.
Yeah, the robot gallery there. I'm in Carmel, Indiana, which is the North American headquarters for Visual Components, visiting my colleagues here. And you know who else is in Carmel, Indiana?
Who else?
Bradford Ferguson.
Yeah, he lives in Carmel or near Carmel.
He lives in Carmel. He's just a couple, yeah, his office is just a couple miles from here.
Interesting.
In fact, what you are about to experience is what he's about to experience live in about an hour from now. So he's going to come down, and if you wonder what I'm seeing and what I'm looking at right now, we can go ahead and do that. So I just have to go ahead and go to my display.
Right.
And I think, do you see this right now?
Yes. Yeah, you can see it. Yep.
Okay. So right up here, I am looking at a really big FANUC robot that's going over and getting ready to grab some boxes.
Oh, I see.
Yeah. And it's going to pick them up off this conveyor. See it? It's a robot.
Yeah.
From a company in Ohio called Kaufman Industries that makes, like, some pretty interesting end of line palletizing equipment. This is a project we did with them a few years ago. That's just, I just love it because of like all the detail that they have in here.
Right.
And trying to figure the throughput and everything like that. We had to make sure we were doing at least 60 cases per minute going on through here to be able to get them through, and dealing with an existing environment. So you see the shuttle conveyor over here, it was trying to figure out how to get around that column which was in place. So I mean, this is where they had to put it. This is pretty neat, is that right now what I'm going to do is I'm going to teleport us to another part of the environment. And it's like, let's get ourselves right here in the middle. Whoa, see, I can get up and walk around here, and I'm going to try to teleport us. It doesn't want to teleport, of course. It wants to misbehave right now. Oh, right, here we are, like right in the middle of this system. So you see how these robots are just taking the boxes, putting them in the right location. So when they come down here, they form just right. And there's a gate that's going to hold them on down there to make sure they go in the right location.
Yeah.
Yep. And then let's go right in front of this. Oh, come on, I'm trying to get this guy here. Okay, he's misbehaving today of all days. There we go. I'm gonna get right in front of that right there. So here is the shrink wrapper. Yo, okay, you see it coming around?
Yeah.
See how the whole thing works?
Yeah.
Just going to go around, and we just
had one of those, much smaller.
I had one of those. And again, I mean, it's like these crazy robots that are just pushing the boxes around where they're supposed to be to make sure they line up just right.
Yeah.
I mean, this is really cool in VR when you sit here and you play around and get to watch how everything works, and you're able to tell, okay, did we model this thing correctly?
Right.
Now this thing is like, okay, yep, there we go. So it had to wait for the robot to get the pallet in there before it could jump over and get the next one.
Right.
You come in here and you get this idea of scale. It's 1-to-1. It's just unbelievable with the perspective. So you actually have to put these things on to figure it out yourself.
Interesting.
And now, actually, you can download the viewer for this for free, and it will work on your phone.
Huh.
I can send this to you, and you can look at it on your phone.
That's interesting. Wow.
Yeah, and if you get the Windows version, which is also free, and if you buy this stuff here, the headset, you'll be able to go ahead and do it yourself. Now I've got to see where I am on the floor. Okay. So sharing the screen. So I guess I'm back in view, so you can kind of see what I have right here.
You can see.
Yeah. And you can see my hands out here, right?
Yeah.
We even have a version where you can become a human being in here and actually walk around, interact with stuff.
Oh,
yeah. So that's my day job.
That's your day job. Okay.
It's basically I play a video game all day long.
Right.
Yeah. Oh, see, right now, if you wonder why everything's going, is if I close my hands, I can pause everything. And then release it, and then it will just kind of go again.
I see.
So when something like really interesting is happening and I want to see it up close, like, oh, stop right now.
Yeah.
See how this mechanism works. And then I can look at it and then sort of see that that's how the gate mechanism is going to go up and down.
Okay.
So, yeah.
Very nice, Scott. All right.
Yeah.
Very cool.
All right. So should I come back to reality here?
You come back.
Ooh,
No, you come
oh,
back.
look at everything. I better stop screen sharing first, otherwise
Yeah,
everyone
we
at
got
home is
idea.
gonna get sick. Yep.
All
There we are. We're back.
right, good.
We are back.
Well, that and the VR headset kind of keeps your hair in place, Scott. So that's
Yeah, yeah.
the other
Okay. Well,
advantage. Yeah.
I've got something else to get my hair in place over here somewhere. Oh, just a second.
Oh, you have a new hat.
So since I'm in Indiana, I have to wear a hat. That's what everyone does around here. I look like a farmer.
Well, okay. So in
Yeah.
addition to getting yourself to Carmel right now, you've also been in Muskegan. You've been in.
It's not Carmel. That's in California. It's
I'm sorry,
Carmel.
Carmel.
They don't pronounce it anything. It's just exactly the way it should be pronounced. It's not
Right.
like some odd pronunciation. It's Carmel. Now,
I
do you know what Carmel is also famous for?
what?
Traffic circles,
Well,
roundabouts.
yeah, he has 19 of them or something, or 18.
Oh, way more than that. I
More
mean,
than
there's like
everywhere. Yeah.
they're like all over the place, and it's really well laid out. I mean, I'm impressed at the traffic planning, how well laid out it is, and they're sane traffic circles.
Uh-huh.
They're not these crazy ones that get
Right.
over engineered
Right.
that no one can figure out how to use. I mean, they're basically, you know how the traffic circles are going to work because they're all pretty much the same.
Yeah.
And some will be a little bit bigger depending on the flow of traffic, but basically nothing too fancy, but they connect together really well. And I've taken FSD from the hotel back and forth for a couple of days now, in the morning, during the middle of the day, at night. Works like a champ. I mean, just it's unbelievable, from parking lot to parking lot, just going on out, going on down, just everything. I don't have to disengage. Different traffic patterns. It understands how to drive. Now, one advantage is that everyone in Carmel, sorry, they're so used to driving around traffic circles. They all know how to do it.
Yeah.
It's not like you get into these towns where like half the people, like, they've never seen a traffic circle before. So they all drive it, and they drive it correctly, and FSD just has no problem blending in and doing really, really well. So
yeah, my most fun travel circle or traffic circle of all that I've ever been in was when I was in Ireland, and I was in a left-hand drive car.
Oh yeah.
With all the stick shift on the wrong side, and it's like I was pretty sure I was going to die. So
Sticking this hand, you're going, yeah, exactly.
don't know what I'm doing.
Yeah.
All right, so you've been to Muskegan, you've been to Austin, you've been to now since we've last talked, you went down to Austin and then over to Muskegan. You've been traveling all over the country, so you probably have a whole bunch of stuff to share with us. But I was mostly interested, maybe just to start off with the fact that we should take a victory lap after the meeting in Austin.
Yes.
Because pretty much we hit it out. You hit it out of the park. I hit it out of the park. Even Warren Redlick hit it out of the park in terms of where we're headed with Optimus. You said 7 to 10,000. You worked through that whole process, and we tried it all different ways of coming at the number, and we kept coming up with 7 to 10,000. Elon has now confirmed that. So
at scale, he's doing it. And again, it comes down to the number of actuators and the complexity of them and what it's like to scale them up, and us trying to guess what's it going to end up costing in the end.
Right.
And so, 10,000 makes sense. He says that, once you scale it up with a sale price of 20, about 1,000, he said 1,000 bots in the factory next year.
1,000 to thousands to a few thousand.
Yeah, and then after that a lot, but next year he said probably about 1,000, which I was kind of hoping they would get to that. Looking at how things have kind of been a little bit slower, I was expecting at least 100 next year.
Right. But
to see that they're thinking they can get to 1,000 is pretty good. And let's remember, I think it was like right after the meeting, Julian Eberts, who is on the Optimus team, put out a post. It's like, well, now that we have 2 in the factory, how soon before you think we have 10?
I didn't.
He posted that, and that was last week. And my feeling is like,
now,
if there's now they've already identified it, they already have it, they've already built 10 bots, so we know that. And we've counted, I think, about that many bots that they have around there, so they probably have at least that, plus more, because they're going to have them in the factory and they're going to be doing other things with them. So they must be very close to to finding these other operations to work in, that other
Right.
low-hanging fruit.
And of course, then they came out with a post later that said, no, we won't be selling them at first. We will be renting them. So that was another confirmation of the kinds of things we've been talking
the
about.
expectation.
And
right,
also,
now,
yeah.
now
also,
you're gonna have Cern on tomorrow, because he's probably going to be
yes,
really boasting tomorrow, because he got a lot of interaction with Elon on some of his posts. The first thing, he called Elon out, saying Elon's completely wrong about this $25 trillion valuation. He's low. He's really, you know, and then he says, here's why, the numbers, and they just get really nutty.
Yeah.
So Cern's got like a $250
$50
trillion value. It's like, okay, you know, it's like, I understand where the numbers come from, but even I'm not going to step out on that limb. That is just insane, which is why, you know, ARK Invest, they probably didn't put it in there, because they said, okay, people are already going to criticize us for our crazy valuation for Robotaxi.
Right.
When we show them what Optimus is, because they already did some stuff on Optimus, they already know what's going on. They're just like, we're not putting those numbers out because no one is going to believe us at this point.
Exactly.
And it's not just that. I've spoken with 𝐒𝐞𝐬𝐿 before. He's run numbers too.
Yeah.
And he keeps on having to divide by orders of magnitude
to
get them down, because he says if he actually publishes his real numbers, no one will take him serious.
Yeah.
Because it really gets that crazy. So you have to be extremely conservative. And then again, Cern backed some of that stuff off. They said, like, you know, how quickly before you start generating the kind of revenues that Apple is able to do with it. And you don't need a huge number.
Right.
I mean, it's like some of these off the chart kind of valuations, it's because, you know, we've got 2 billion robots out there.
Right.
And which, you know, Apple has about 2 billion handsets, or maybe that's what the, you know, there's large numbers like that.
Yeah.
So you could say those are crazy numbers, but what if we dial it back to a more sane number, like maybe 1 or 2 billion bots? What does that give you? And then you start running the numbers and go, wow, yeah, that's a lot of revenue. And then you put the multiplier on there, and it's like, yeah, easily you get these very large valuations for it. So it's a type of, you know, look at Cern's numbers, how he does that, and follow along at home, and try to do it yourself, and try to find where you think the flaws are. And I haven't really found any flaws in there. But at the same time, I know the numbers are so crazy that it's like, I'm missing something somewhere.
Yeah. So then if we dig a little deeper, Elon talked about the fact that there was one mechanical fix, or one mechanical aspect that was still needing to be finished or redone or something. And
yeah, he's talked about another hardware revision before they're ready to scale, which is what I was expecting.
Yeah. And that, you know, and I'm thinking everybody thinks that's got to be the hand arm, right?
Oh, it's going to be the whole thing. I mean,
it's the whole thing.
Basically, we know the 22 degree freedom hand is coming along, and from that, I speculated they're probably going to be redoing the whole thing. And he more or less said that there's a hardware revision,
right?
And that probably means everything else. So they may be re-looking at things like, okay, why isn't our bot able to walk as quickly as we want? Is it a software limitation? Is there some mechanical issue? What's the issue? So they may be doing a rethink on a few things. They may have, you know, identified some new actuator designs or something else that may slim things down, make it a little bit better. We did get some confirmation of the 20 degree freedom hand. Now, this was something that we were able to tease out from background, not what Elon officially said on the record. So on the record, he said Optimus will be able to play the piano.
I know, and I was like, go Scott.
But we already knew that, and that's because for the 22, the current hand can only do this.
Right.
It can't do that.
Right.
Okay. And so we were kind of guessing, it's like, okay, that's where you're going to get 4 here, plus you're going to get the additional knuckle. That's like an additional 8 right there on top of the 11 that gets you to 19.
Right.
They may be including the wrist degrees of freedom in that 22, which I suspect because they're moving actuators back here. So it's a fully integrated lower arm and hand system that they have with the 22. The question was how much independent control you're going to have of each finger. So we know they can move each finger individually, because it's an individual actuator. You have it. You know, you could potentially say, I only want my finger to be able to move straight down, which would require like a single actuator for that, and then be able to do this. You know, right now it does it all as one. So it's one actuator.
Right.
I don't think they're going to have like 2 actuators for each finger to be able to do that, unless they decide that we want to have one that allows you to go straight and then individual ones for that. I don't think that's a possibility. But the question is whether these are going to be able to move independently. And as you know, there was a behind the scenes tour of 15 lucky individuals got the golden ticket to go on a tour with both Elon and Franz of the factory. And I met 3 of those individuals the night before at the Clive Bar.
Okay.
And they wanted to know, it's like, what questions do you want to ask? And everyone's coming and asking all these, this like, no, stay on topic. Don't ask, about X or SpaceX. And it's like, you got to talk about Tesla kind of thing, stuff that you see in the factory, stick to it. And then, what are the Optimus questions? And one is about the hands.
Yeah.
And Lance Webb, who is in there, was able to sort of ask, prompt Elon the question about the 20-degree freedom hand. And we wanted to know, can it do this?
Right.
And to do that, you need independent control of all of them. And Elon said, no, you cannot do that.
Interesting.
Because he didn't see that is something that was useful.
Interesting.
You don't really need it.
I see.
And of course, when I stated that, some people's heads explode. What do you mean it's not useful? It's like, okay. But for most mundane things, you don't need to. So it means it can really only go, they go out together. And that tells us there's only one actuator for those 4 degrees of freedom, what they're calling 4 degrees of freedom.
Right.
I don't call those 4 degrees of freedom because they're linked together. Degree of freedom is like usually means something that's controllable. So that means you're gonna go from 6 to at least 7 actuators to be able to do that. And that's my suspicion. But it looks like they're moving actuators out here. If it's because they have to put 1 in there, that's not moving your actuators out of the palm. So it sounds like he said they're moving most of the actuators out of the palm. They may still be out there, maybe for like the thumb or something like that. So the hand design is going to be interesting. And the fact that the actuators are moving in here is why I'm saying it's fully integrated. It's not like a hand that you can snap on and off because everything is contained in the hand. It's a little bit back there.
So Scott, my question then became, as a manufacturer, but as a manufacturer who was not doing anything at this level of complexity, but buying products sometimes that were at this level of complexity and knowing something about the upstream, in terms of the products, it seems like the actuators themselves, now these are really small actuators, they got to be really, really precise, et cetera. So I'm sure that there's some complexity with regard to manufacturing those, but do you see any significant issues with regard to, once they have the design fixed, with being able to ramp those up? Do you see that?
They should be able to ramp it up. So the actuators I have in there seem to be fairly complex and maybe more than they need to, because you just have tendon controls to be able to make them open and close.
Right.
And it may be that they realize that the design of the actuators can be made a little bit simpler and a bit more compact. And there certainly are a lot of very interesting other linear actuator designs you start to see out there. So they may be realizing, maybe we over-engineered it. Maybe we can come up with something that's a little bit more effective. And maybe it's a slightly smaller package. And if it is a smaller package, then maybe that's the whole idea, is that we can start to fit them back here. It might also mean that they're able to lighten and tighten the other actuators they have for being able to make the wrist move. So that gets it to be a bit more compact. And that means you might be able to do some other interesting things with the palm, but not making it so stiff. Potentially you could get, I don't think there's shoving a degree of freedom in there. I mean, that's something you can think of. If they're not counting the wrist, the other 3 in there might have something to do with scrunching of the palm, but I don't quite think that could be. But I could be wrong. There's a lot of degrees of freedom you could potentially have there. I suspect that they may see that there's some other actuator designs they could use that are maybe a bit novel and more compact, better on energy usage. And which may allow them also to do some changes in other places.
So, but in terms of everybody's very interested on my channel as to when things are going to happen. And so at least one of my commenters thought it would take, as much as 18 months from design lock to full ramp on an actuator. And I was thinking that seemed extremely long for an actuator, unless I'm missing something about the design of an actuator, fully ramping up would be much easier than an automobile. So you'd be talking
I think if you're going that you haven't started to assemble your team and everything else together, you could be looking at 18 months, but they've already been hiring everyone for it and probably working on prototype lines and prototype designs.
Right.
And they know what the sourcing is. So while they may not be designed locked, they're probably pretty close unless it's something radically different.
Right.
So I think they are close to being able to do that. And you could be right as far as like big scale. So they're able to produce these things, but they may be able to produce them at a high volume and low cost yet. So if you're talking about like 1,000 bots next year, well, you can do that without having the line scaled up yet.
Right.
But then, then he talked about, and then like, a lot right after that.
Yeah.
So, and this is what like a lot of the other robot companies are talking about is that, they feel that next year they can all do like 100 to 1,000.
Right.
And that's when they're going to start to do the scaling, that hopefully things will be quite locked. And then after that, it's like, whoop, yeah, you can go. And I think it was Jim Fan who uses the example that he says, at first gradually, then suddenly.
Yeah, then some.
That's what it's going to be. So we're going to go 1,000, zip, 1,000,000. You could almost you'll easily see it scale by 10 times the year after that. But
Yeah.
I have a feeling they could go more than that
in the first year.
Following year. So it'll be one of those kind of lumpy things that if we plot the curve from like this year to 2030, we'll say it's a 10x each year. But what it might be is just like, we're not really going anywhere, and we kind of like suddenly go from almost 1 this year to 1,000 here.
Yeah.
And then and then
100,000.
whoop, we bump up, and then going from a million to 10, then it will like maybe go more like a factor of 10 or a factor of 3 after that. But then you begin to look at it and say, oh yeah, by 2030, we're clearly at 1 million. Or maybe
well, if you compare it to an automobile, I mean, we're expecting 75,000, Cybertrucks this year. It's certainly not hard to think about 100,000 Optimi the second, in 2026.
Yeah.
That would be
should be a lot easier
compared to doing a Cybertruck. Yeah,
absolutely a lot easier. Absolutely.
All right. And so, and the complexity to me, and again, maybe I'm completely wrong on this, but the complexity to me I don't feel like it's in the motors and the actuators and stuff. I feel like it's in the packaging. In other words, how it all fits inside of the hand, fits inside of the wrist, fits all the way up the arm and into the shoulder, all the ways that they have to fit in there, and then everything has to move. And it has to move consistently. It has to not wear out.
All the wire harnessing and stuff like that. Yeah, that's probably the thing that they're trying to figure out how to design that, and whether that's going to be like the weak point of everything from all the movement.
Okay.
So yeah, probably mechanically the most intricate one is going to be the hand of getting everything in there.
Sure.
And then that's going to get kind of mounted on there. And then you're right, you're going to have the control systems that are going through, which is just routing the wires, and that's part of good design. So once you get that design in there, it should be pretty easy to put together. Yeah. So I'd agree. It's maybe the most complex part of it, but it's not going to be like putting a watch together or something like that. It's going to be easier than that. Maybe
not even as complex as a computer. All right. What do you call it? A smartphone. All right. So, by the way, you might have missed it, but Elon did say 1,000 to 1,000 to a few thousand in 2025. That was his exact quote.
Yeah.
1,000 to a few thousand. So I'm sticking with, in my mind, I'd like to just see that few thousand. That'd be great.
Yeah. It could be. And I think he said like a 1,000 actually working in the factory.
1,000?
Maybe he's talking, and then maybe a few thousand might be that, and then we've got the others for training or doing other things. Yeah.
All right. So what else popped up this week as you listened to Elon, or as you traveled to Muskegan, or any other things that are not widely reported yet?
Let's see. What's not widely reported is, from the standpoint, I mean, the Muskegan event was great. It was nice to meet everyone up there and to see so many Cybertrucks together, which is, in one place is something else.
Didn't you have a fun ride up there? Didn't you take a Disney, well, not even a Disney, more like a Magic Mountain ride with some old lady or something?
Oh yeah.
And I'm allowed to say old lady because I'm old.
This is Tesla Granny. That's that she knows as. So she's one of the members of the Tesla Michigan Owners Club, early Tesla adopter, and along with her son Kenny, and they have a Cybertruck and a couple of different. I think they have also Model X and S, and they always go to these Tesla events, and she is so entertaining, so fun to be around. She's just hilarious. And someone just got a Model S Plaid, and had not done a launch yet, and let her do the first launch with this thing. So there was like a secret location outside of Muskegan where the road was officially closed off, so they had permission for it. It was properly insured and everything. And I think it was like a little over a mile stretch of road that was paved, and then it would turn to dirt after it. And so she did the first launch, and she came back and she was like, come on, anyone want to get going with me? Don't be afraid. And I was just like, I just jumped right in the back. Because I trusted her, I trusted the Tesla and everything else. I knew she could do it. And it was great because I think she's maybe like 5 foot tall and stuff like that. And she needs a scooter to get around for the most part, but she can still drive a car. And we got out there and she launched that thing, and we got up to 151 in no time. And then we started to run out of course. And then the braking, it wasn't like super hard braking, but it was like, you had to bring it down, and we just got it before we ran out of asphalt.
Wow.
Or sorry, in Michigan, asphalt. We say asphalt in Michigan. And then turned around and came back. And it was something else. I mean, the acceleration you get out of that, you really feel the what it can do. It was an impressive launch. And then like the whole day you're just watching it. And then there's like a Model X went against a Beast. And it was interesting. The Beast had it at the start. And then the X was eventually able to overtake it. But the Beast is really quick off the line. It was incredible. So this wasn't like a normal foundation. This was the Cyber Beast against the Plaid X. And so the Plaid X maybe had a little bit of advantage because it wasn't quite as heavy. But still, I was surprised that the Beast was able to jump off the line faster.
So it would seem to me that there's an opportunity out there for somebody to set this up as a ride. I mean, to to charge people $10.
You could, if you go to like Legoland and other places, there's a ride based on the KUKA robot. It's called RoboCoaster. And you can go in and you can actually program it. So you sit in what is like, the cockpit of a fighter jet. And they get you strapped in, and you go in and you program all the different moves and how many G's you want it to be and how fast and everything else. And you're sitting there and they'll go around and move you on that. And that same KUKA arm, which is the Titan arm, they have a version of that also that's at a Harry Potter world. So if you've ever done the Quidditch ride in Harry Potter world inside of Hogwarts, you are actually riding on a KUKA robot that is like throwing you around in space.
Interesting.
Like yeah.
So anyway, so you had that fascinating ride. You met a lot of folks. You also drove a lot of this time. You flew some, but you drove some, or?
Yeah, I had to fly, drive, everything else. So I drove from Florida to Boca Chica to see the launch. And then the question is like, do I just go from there to Austin and then have to get to Muskegan? But because the events were so close, it just was insanity. And I wanted to stay for the after party and everything. So I decided to drive up to Michigan early, spend a couple of days there, taking care of some items, go to the airport, fly down to Austin, flew back with John Gibbs. So we then drove up to the Muskegan event and were able to get there at a reasonable time. So, but that was like a 5:20 a.m. flight. So it was like, we went to the after party and everything like that, got back to the hotel and packed, and then basically headed straight to the airport. I think we got 3 hours in there, and then, another 3 hours on the flight, and then drove up to Muskegan, which was just beautiful. The weather was just something else. And there's going to be an event next year, and that's going to be TeslaCon. That's going to be the big one. That's where all the owners groups come together. So it's official. It's going to be there. Beautiful venue. I mean, just unbelievable. The beach up in Muskegan is just, you would think you're at the ocean.
Yeah, I've actually been to Muskegan once when I was 9. I took the Muskegan to Milwaukee ferry.
Probably, yep.
And so that's the only thing I can remember about the whole trip. But I
think that ferry is still there, and it's like the only one in the Great Lakes that's still allowed to use coal, because it's like a traditional steamer, so you can still take the traditional one, but all the others are a lot cleaner. But the beach is impeccable. I mean, it's just beautiful sand, a lot of things to go around there, and the water is just so nice and clean. And as we like to say up there, no salt, no sharks.
So let's go back to Optimus for a minute. So the Optimus, in a conversation I just had yesterday, I think, yes, it was with Nicholas Gibbs, he was talking about the fact that he thinks that the Tesla, the FSD could be real, or the Tesla car, the Tesla automobile, the Model 3, Model Y, whatever, could be released as a robo-taxi tomorrow if it had the rest of its skills in place. So just the basic skills, backing up, Y turn, K turn, whatever. You know, there's a bunch of basic skills that it still doesn't do. But once those are in place and they do them well, he says he thinks it's ready to go because it's probably already, as we know, 10 or 20 times more safer than a regular car. So then I after the show was over last night, I was thinking to myself, well, why wouldn't that also be true for the Optimus bot? At a certain point, it's, and you and I've kind of talked about this too in the past, but it kind of gelled for me that at a certain point, maybe that's in March or something after the final mechanical design is in place, and they're starting to build these in a little more volume, that it will be good enough to do quite a few tasks and do them quite easily, maybe even start to mimic, fairly easily mimic other tasks because it will have the, whatever it is, 80 basic tasks that it will be very good at. I mean, isn't that kind of where we're headed? Almost like car?
So it will have a lot of foundation tasks in there. And the question is, at that point, are you able to demonstrate what to do? Yeah. So we know there'll be an LLM integration. We were expecting that. That was one of the questions that was asked, and yes, you'll be able to speak to it. I think the other thing you point out is that you will be able to demonstrate what you want to do without having a telerobotic kit. Right. So right now they're doing it with teleoperation because they want Optimus to see it from its point of view.
Oh, okay.
Because that's the quickest way to do everything. But the other way to do the demonstration is for it to observe what I am doing, you're doing, without us being set up with telerobotic equipment. Right. And then it to be able to understand what we're doing with our left arm and right hand, and then kind of do the transformation. And that is kind of just a mathematical problem that, if it hasn't been solved, will probably be solved pretty soon, of it being able to, it's almost like this theory of mind that, you know, if I'm watching what you're doing, I can imagine what it would be like to do the same thing from my point of view. Right. I'll just kind of look at that. And that's what the demonstrations are going to be, is that once it gets up to that certain level, you just show it how you want a particular task done and be able to do it. So on the factory floor, it should be as simple as demonstrating, these are the parts you need to pick up from over here at these bins. This is what you need to look for. You need to put over here, and this is the order of how you need to drop them in. This is like a tool you need to take, or an operation you need to do, through both demonstration and probably also through like a large language model, because I'm trying to think of how these bots deal with like lists of operations to make sure it's following a list faithfully, always doing the same thing faithfully, as opposed to it just making things up along the way. Because, you know, the LLMs, it's like one token after the other. Yeah. And somehow it's right, but it doesn't actually understand what it said before that. It just keeps on coming out there. Whereas we're kind of thinking everything in a big picture. So there's going to have to be something in there to guarantee that it's actually doing the same task and then doing it repeatedly, as opposed to kind of improvising the whole time. You know, where the improvisation is going to come in is like when you go to pick up something from the bin, it's always going to be in a different location in the bin. Right. But you're identifying a particular part. And hopefully, like, you pick up a part, and if you notice, wait a minute, there's something wrong with this part, this bin's been mixed up, or something got thrown in the bin that's not supposed to be there. Right. You identify it, because that's possible. You know, you're looking for a bolt. Sure. And a lot of times you pick up one and you go, wait a minute, you know, it's supposed to be a 3-inch bolt. This looks like a 1-inch. So you would know to reject that. So that's where it would have to go and do the error checking. But, you know, there's a certain order of operations, and you just can't mix them up.
So on the foundation tasks, is there now a checklist? Do you think there's how many of these foundation tasks, and are there are there levels? Is there like 30 really foundational tasks and then another 300?
Yeah, I'm not sure how many. I mean, it will come down to, probably different kind of grabbing tasks, right. Lifting things up, moving things around, different kind of positions. So it may be a fairly small foundational set that you would have, that you've taught again. One of it's like, opening a door. Right. So that might be a task you want to have. I'm not sure how important it is for Optimus to sit down, but maybe it is, because they keep it time. Oh, there's all these tasks that you don't know your legs. Okay, sit him in a seat. To take the load off his legs, just like we're doing right now. Yeah. But there may be a task later on. So getting up and down, doing that, grabbing different kinds of objects. So there could be a lot of different things. So grabbing a pencil is very different than grabbing a hammer, than grabbing a drill. grabbing a box, it's like two-handed grabs, one-handed grabs. Sometimes the kind of grasping that you need to have, those could be different. So those might be some of the foundational things that you have. And once you have enough of them, grabbing a ball, there's going to be different size balls.
Yeah.
And then,
That's what I'm
understanding that
thinking.
they're
That's
all
what I
kind
was
of the same.
wondering. Yeah.
Fragile versus
Yeah.
something which is solid, and the difference between grabbing an egg versus grabbing a baseball. They're similar, but one of them you have to be kind of delicate with, and the other, you might have to grasp it a little bit harder. So there should be enough examples of that when it sees something that's not in its training set, it knows what to do.
Right.
It's like, it's kind of a blend between the two, and I know exactly what to do.
So the foundational task would be the grabbing itself, right? And then the grabbing different things would be a next order level of foundational task. But it would be
grabbing, placing, learning to take objects of certain shapes and put them in things with other shapes, figuring out how to get parts to match. That's what's going on the shop floor, is that you have these fixtures with different jigs on there, and you pick up a part and you need to place it the particular way, make sure it goes in the right way.
Right.
So, how much of that is that you are demonstrating it to that this is the way the part's supposed to go in there, versus take that part and you figure out how it's supposed to go in there, and then it might go over and look around, and then it's like eventually solve that puzzle. Oh, that must be the way you want it to go in.
So you are in the business. You're in the robotics, well, you're in the automation business, which includes robotics. So I don't know if you still are, I assume you're still talking to owners of manufacturing facilities, people that are setting up new manufacturing lines, trying to, get certain new products produced. What are they thinking about Optimus?
There are some, and I've had some discussions with some bigger companies, and they're all looking into that. They're starting to consider how it could be put in there, and they're serious about it. So not just small companies, but some larger, more serious companies are giving it consideration and know that that's going to be coming. Not just Optimus, but generally humanoid bots in general.
Right.
They're seeing that, and they are now moving, let's say, in that direction to figure out how to work it into their designs. So they know it's coming.
Okay, because I can remember in the early 90s that my partner and I were just champing at the bit for the internet to become a thing. I mean, we literally were probably one of the first 100,000 websites that was created, because we were doing all the work ahead of time, because we knew that if we wanted to be really competitive, we wanted to have a website, we wanted to be able to do all the things that the internet could do. So it would seem like the forward-thinking manufacturers, especially manufacturers right now, wholesalers, distributors, I suppose, also would definitely be paying attention to this process and trying to figure out how to, benefit and get ahead of their competitor as a result of these things coming. You're saying that is starting to happen.
Oh yeah, that's starting to understand what to do when they're available.
Right.
And how to specify it and understand it. It's sort of like putting in an industrial robot, but not quite.
Yeah.
And it's sort of like trying to figure out, well, how the human labor goes in there, but not quite. So there's some blending in there, and understanding at what stage do we start specifying the use of these bots, and what are the the attributes it has to have that we're looking at on our checklist to be able to understand, is it a good one-to-one fit for a human? Is it a replacement, or is it a fraction of fit? Is it one of those that it's only half the speed of a bot of a human? But because of the costing factors being a little bit different, how would we redesign everything for that? And looking also at the infrastructure that goes along with it. You've got charging infrastructure that's going along with maintenance infrastructure, everything else.
Yeah, I know from my standpoint, I don't know whether other people are looking at it this way, other manufacturers are looking at it this way. From my standpoint, I immediately just went around the building and started looking at each job, each human that I was employing, or my clients were employing, and saying, could a robot do that? Would it be an advantage? What would be the issues? So I didn't kind of look at it holistically. I was looking at it position by position. Which one of these positions does it seem like it would be the smartest to do first, second, third, etc. I suppose the next level thinking would be, what products could I bring back? What products could I onshore that I'm now making overseas if I had a robot to do it. I think that would be the second level that I would go to, because I was always like every, I don't know, at least once a month, I was contemplating, should I be making this? Should I have a supplier make this for me in the United States? Should I have a supplier outside the United States make it for me? Even the products I was already making, should I take those offshore instead of making them domestically? So I could imagine almost the reverse process going on with the robots, because there may be many things that could be onshored.
Yeah.
If
I think the only reason you're offshoring it is because labor rates are
almost
way
always
lower.
almost always, because the raw materials
Yeah.
cost the same the world around.
Yeah, the same. And then of course you've got transportation, which is
Right.
not cheap,
Right.
and supply chain, and the fact that it takes a long time. A few years ago, I did some work with Reebok. They make shoes,
Yeah.
and their whole thing was basically custom shoes that they could get out in no time.
Right.
So, and that's something they just could not do overseas. So they were doing this production in Lawrence, Massachusetts, which is just outside of Boston. And I'll tell you that, labor's not cheap there, though they were automating quite a bit. And that's how they were kind of getting competitive advantage. The fact that it was like a new shoe, there was a custom shoe that they were able to get out for something like literally within like 48 hours.
Right.
They
Right.
would say, this is what I want, and we'll manufacture it for you. So keeping it locally helps on transportation costs.
Sure.
And now if you can bring the cost down to be commensurate with what's overseas, and then the fact that you don't have to worry about the distribution and how do are you going to fly it over? Are you going to put it on a ship? What are you going to do?
Yeah. Yeah. Well, the biggest thing that we found on small products, because I was mostly in the small product area, on small products, one of the biggest costs for domestic was packaging and the sophistication of what you needed to do to prepare the final product for the Walmarts and the Kmarts of the world, in terms of the barcode labeling of everything, exact placement on a pallet, the exact kind of pallet, all the really, really tight requirements, and that US employees aren't as interested in being as exacting as some of the Asian countries. They're have more of a mindset for this exactitude, and maybe because they're still in the dirtier industry part of the world, they don't mind doing this kind of repetitive activity all the time. But if all of a sudden you've got a robot that's going to do exactly the same barcode in exactly the same place every single time, always going to put the package on the pallet in exactly the same way, all of a sudden, again, you eliminate a lot of the advantages that are over in China.
And I can imagine your packaging requirements when you have to send something halfway across the world is a little bit different than if you're just talking about, the next state over or something like that.
Right.
So there's a lot of excess packaging that you would need to have.
Yeah. That's possibly true as well. Hadn't thought of that.
Yeah.
Yeah. So, okay. And then anything else that because again, you've been on the ground. You've actually been a reporter in true form. Is there anything else that came up that you think's worth reporting on?
Oh, let's see. I mean, the only other thing which is going to be interesting is I think there were some leaks about the mini Starlink receiver that will be coming out. That'll be very portable, and that'll be interesting because I've got my bigger dish mounted to the inside of my Model Y right now, and it's working really quite well. But still, it's a bit bulky. It's a bit of a power hog and everything else. And so it'd be nicer to have a smaller, more portable one that'd be able to bring on trips more easily. So I'm looking forward to when that becomes available, and it'll probably be more than enough capable for anyone that's on the move.
So Elon may or may not have been sandbagging, all along. He said, look, this is just a product. These Starlinks are just a product for the folks that can't get good reception. And it's never going to be for the average user in the city because blah, 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 blah.
It's going to take, now that they have the right number of satellites up there, I think you're going to see an explosion. And when they get Starship going, and they start putting up the version 2, it's going to be a big change. So they last night they launched another, I think 22, 23 direct to cell satellites out of Vandenberg.
Right.
So that's coming more and more. And of course, the other thing that's just you've got this rural act to try to bring high-speed internet to rural communities.
I reported on that this morning.
$42 billion and like still nothing. How many billions of dollars and still no superchargers? What, 7 or something like that?
7.
Government at work. And it's just, and it's because what they did, typical government kind of thing, is like they put in some wording that says it has to be hardwired.
Yeah.
So it's like, oh, so you're the geniuses that know, you're telling us what the solution has to be ahead of time without necessarily knowing that there could be other potential solutions. And we know there's a potential solution. And for that amount of money, every other person could be given like a Starlink dish.
Yeah, right. Yes.
But the thing is that we know that if you had that amount of money thrown at the problem, the Starlink dishes wouldn't cost $500 a piece. They would be costing like, $50 a piece at that point, because at scale, it would be absolutely nothing. Absolutely nothing.
So my concern with that particular story that I gave this morning, after I did the story, and I thought, by the time if these are only installed 100% by 2030, which is what the article said, won't they be completely obsolete? Won't people just actually have already bought?
Oh yeah. It'll be absolutely obsolete. So, and at that point, by 2030, you will have so many Starlink satellites up there that you will have way more people per cell. So right now it's limited to the number of people you can have per cell, because there's just not quite enough coverage.
Right.
But you'll get more and more. And again, Starlink was never designed for the city. It really was designed for rural communities in those areas that are like between the rural and city areas where the fiber is like not so good, which is like my example, is the fiber is crap where I am.
Right.
My neighbors are always out, their speeds are slow, and it's much better for me to actually use Starlink, even though I'm kind of in a
city, sort of.
Would you'd say a city area. But for rural, I mean, if the idea is like people literally in the middle of nowhere, it's there. The solution exists. You don't have to wire anything. You don't have to do anything. You don't have to tear up roads. You don't have to, tear up the soil. You don't have to do any sort of destruction to the environment.
I mean, they should literally stop. They should literally stop that entire project immediately. Maybe this
they should.
Maybe this is something that the next president could do. Just stop the project immediately and just start putting in Starlinks, and they'd be done in no time.
So really quickly. And then as soon as you dedicate something like that, then they would be able to ramp up their production line to start dropping way more of these things. And it's like, well, we need to put more satellites up there. Okay, we can ramp that thing up as well, and we can start launching rather than twice a week out of the Cape. Maybe we get another pad or something like that set aside for it. We could be launching almost daily if you want to get them up.
So this is a question that maybe nobody listening cares about but me, but I have had this on my mind forever. If you have a Starlink, a satellite dish, you have the dish, okay, the biggest one, well, the ones that's on these ships, I guess. So the ones that are on the ship, they just have the one dish, and that serves all the people.
Yeah. So basically, I mean, businesses are able to do this as well. So we're not just talking about individual homes, residential rural, but also rural companies can do it. So if you get the professional dish, they're dedicated. You can serve a lot of workers, at the same time with the bigger dish. Now on the cruise ship, because it's basically a small city, they have more than one of those dishes. They have at least a dozen or more kind of around there, but they can handle it. And it's just a question of how much you're willing to pay on a monthly subscription to be able to get that.
All right. So the reason I cared about that was I was wondering about these, sub-equatorial Africa location.
Easily. And you can do that without impacting us in the US.
Yeah, and so
it doesn't affect our bandwidth, because they're flying over there for free doing nothing.
Right. So if you put in not even the mini dish, let's talk about the dish now.
Yeah.
Put that dish in.
You could do a whole village.
A whole village.
Yeah, easily. You could set that up, and you could do a whole village. And again, the thing is, that's not affecting our bandwidth one bit. Because it's sitting there like not doing anything, because it's over an area that there's no subscribers. So you throw some subscribers down there, and not only do they get it, it starts subsidizing the whole system, which means it's even better for us, which means the rates are going to go down more, because the more utility you get out of each of those satellites, then the lower the cost goes down. So if you start looking for all these places in the world where people have absolutely no internet, and you figure out a way to get that down there, it's going to be better for us. I mean, seriously, I bet if they spent that 42 billion, towards what was going on in Africa, it would actually be cheaper for the projects of doing it here because you're getting the whole system to go.
So,
Absolutely.
okay, to show my
Yeah.
complete lack of
Yeah.
understanding, if you put a dish down
Mhm.
in the middle of that village, does there have to be any wiring at that point, or is it 100% wireless to the person's phone?
Okay, so the only thing you would need, see at this point, you don't even need, you won't necessarily need the ground stations because they're doing the inter-satellite communication. So
Okay.
right now, what you need to do is you need to be able to hit a ground station, but you don't have to anymore. That's why it's working on cruise ships.
Okay,
Because they try to find the ground stations that actually connect to the internet from that.
okay.
And then you would have that dish, and then all you would need is a Wi-Fi router. And
Wi-Fi
you could
router.
set up a mesh of some sort,
I see.
or you could potentially use that to have like a smaller tower that's able to broadcast. So you
Okay.
could potentially use that to come up with like cell phone service, voice over internet cell phone service, and like in the middle of nowhere, you could set up a cell tower, and then the connection to that cell tower could be done with Starlink. So that would be what, and you could just drop them anywhere and they would be solar powered and everything. So you don't need any infrastructure. You could come in with a helicopter and just like drop it down in, a nice high point where everyone is there, have a Starlink antenna on one side that have a little power wall on there. You could easily make these things deployable anywhere you want in the world.
It seems to me like that would be something that the UN could actually do.
Yes.
Provide
Yes,
value.
Absolutely. Absolutely, they could.
It might be the first
you could do
thing
something like that.
ever.
Now let's remember, 3/4 of the planet is covered with water.
Yes. Right.
Okay. So when the Starlink satellites are going in an orbit,
Yeah.
over time, only 25% of the time are they over land.
Right.
Majority of the time they're over water, they're
Right.
over unpopulated areas, and
Right.
they're getting absolutely no value.
Right.
Now, of that 25% of the time they're over land, there's a good chance they're over countries where you're not allowed to use Starlink.
Right.
Russia, China,
Right.
some other countries that have yet to allow them in there. And so that means each of those satellites is probably only being used maybe 10% of the time. The other 90% of the time is doing nothing. And what we need to do is like, let's try to get more utility out of it. So if we can double the utilization of that thing, then that just brings rates down for everyone. So we're not talking about that suddenly, oh my God, if they start turning on in Africa, Starlink's going to be slower for me here in Florida. It's like, no, it's not. No, no, it's not. I'm not going to feel the impact from that thing. And what I'm going to see is I'm going to probably see my monthly bill go down now. And I might see my service go up because, now that so many more people are wanting to use it around, they're going to start wanting to throw more satellites up there.
Right,
so,
right.
Yeah, it is really one of those things that is to the benefit of everyone. The more utility we get out of it, it's like that's a waste. That 90% of the time, it's probably not being utilized.
Right, and as Elon has said, there's like nothing you could do for those folks that would bring them more into the 21st century than the
communication
information that's available.
Yeah, information. Yes, absolutely.
Holy mackerel, Scott. Well, I never knew that this is where we'd end up, from where we started with you wearing some futuristic goggles and taking us around a tour of your facility there in Carmel.
This is not future. This has been around for close to a decade, different versions of it. Yes, it's the most recent version of it, but everyone's just got to kind of get with it. And VR is the future. Unfortunately, not enough people understand the power of using virtual reality outside of gaming when you actually use it for engineering. The
medicine.
Oh no,
they train.
Being able to do reviewing, design review is incredible with these things.
Right.
You find problems with your design like that. You're able to get people to understand what you're doing like that. Right. I mean, that's the whole idea, and it's literally an order of magnitude faster to doing it that way. So more and more people should really look at it. And the thing is, these things are cheap. Okay, getting a VR setup, which is like 4K resolution, that whole thing and all the trackers and everything, it's cheaper than the laptop that you're buying to run it on. Okay, you can afford it. These things are showing up under Christmas trees all the time. And I'm not just talking about the rich kids that are getting it. Just about every middle-class kid probably is getting that as a present for either birthday or Christmas or something like that. So it's not like a huge investment.
Well, isn't the the Amazon one? No, I'm sorry. No, Alpha.
Meta has one. I mean, they have these. We also have like the Magic Leap, which is the AR kind of thing. This thing here is like real VR because
real VR. Okay.
I joke is like we're building these factories that don't exist yet, so there's nothing to augment.
Yeah.
So But there are cases where you want the augmented reality because you might be putting it in a space where you're thinking of retrofitting. So you're more of a brownfield situation where you want to go out there and say, I'm thinking of throwing these robots down around here. Are they going to fit?
Yeah.
You know, what are going to be the issues? So there's advantage, and it's so cheap. It's that anyone that is doing any sort of design or thinking of doing factory layouts, you've got to be moving it. But basically what we're doing, you know, this thing they call the omniverse that NVIDIA has been talking about? Doing it.
You're doing a what?
We've been doing it for a decade now. I mean, basically what you saw is what NVIDIA wants to do with Omniverse. We do it already.
Yeah, I've actually down in San Diego at the Orange County Fair, they were showing how the military already uses the virtual reality classes to train the troops.
Yeah, absolutely. You can do it for a lot of things. In this case, we're using it to help factory designers understand how the factory is going to work or not work. You know,
not work.
They come up with a design, because that's what you want to catch early.
Right.
It's like, oh, that's a bad design. We've got to change this
before you've already routed all the wires. Okay, Scott. Well, thank you so much. I know you've got another thing to do here real quick. We did learn today how to correctly pronounce Carmel if you happen to be east of the Mississippi, and Carmel if you're west of the Mississippi.
If you're hoity-toity, it's Carmel, right? But
well, I have to admit that I have wanted to live and have my address in Carmel by the Sea just because it sounds so hoity-toity.
Hoity-toity. Yep.
There you go. All right. Hey, thanks, Scott. Appreciate it.
Yep.
And all of you out there, it's been great talking to you.